So once you have installed AIG Mode Wizard successfully and you've run the script and also the DIN fastener as well, these are it will appear on your screen. So this is the same for every other language you download. All the language versions, the appearance of the user interface is the same. So on this session, you have your cooling. Here you have your ejection components. Here is your ejection component, and this for other components you need. Then these for alignment components. Then these words you click to create your mode base, and these are your utilities where you create your BOM and your projects. So for this project, we are going to be using a cloth hanger for our example. We are going to design a cloth hanger mode from start to finish. So for this one, I've already prepared the cooling channels, then the gate as well, and the components. Then some layout sketches also prepared already to make the work a bit faster for us. So let's get started. So to get started, the first thing you do is to create a new project. So to create a new project, you go to your utilities menu, you click on create projects, then you can extend this. Then you fill in the details, the necessary details required for the project. So here, company name, you can just say Uche Limited, then you can leave this. Then the project name, you can say Hanga 678 1. Then for the project ID, you just give it you can give it any random number for now. Then you can leave this as well. Designer is where you input your name. So this is my name. I input it. So this is a mode manufacturer. So we can leave this. So it's where you input the name of the manufacturer of the mode. So one thing you should take note about this creating project is you make sure you take note of the project name and the project ID. You can just write it somewhere or just take note of it because you can is if, even if after finishing if even if you have not completed a project you want to create another project, you can create another project. Then if you want to come back to this project, you just input your project name and your project ID, and it will update any new changes you made on your mode design. So you just have to take note of the project name and the project ID. So when you input a new project, even if you create a new project, after doing it and you want to come back to this one, once you still create a new project, but once you put the existing project name and the project ID, it updates the any new changes or any new components you add to your project list. So wait, okay, so you see the message here, project created successfully. Okay, so to start this mode design, the first thing we are going to first start by creating our cavity plate. So for create the cavity plate, you go to the mode base section, click on cavity plates. So we are going to input our parameters. So for this, we need 520 mm, 560 mm, then the thickness of the two plates are equal. So put it both 55 mm. Okay, then we can hide this for now. Then we'll go ahead with creating the mode base, the main mode base. So we are going to use Haskell standard mode base for this mode design. So we select yes for the cutter option, the use of the cutout option has been in one of my previous videos. So the size of this mode is 696 by 696. Then the A thickness 66, B thickness the same thing. Then C thickness 96. We don't need this, so we leave it at none. Then okay. So it starts. So that's our mode is created. As we have all our components of our mode created. So let's start by making a cutout for the cavity. So we just go ahead and hide the bottom components. This is cavity B. So this is cavity B. So we hide it. Then combine made already made a shortcut for my combine function instead of us going back to our solid menu and our utilities menu back and forth. So I created shortcut for most of the commands we are going to use. So we are going to make a cutout for the cavity plate. So this is what we want to cut, and we make sure keep tools is active. Okay, so our cavity plates for our A part is done. So let's do that for the B part too. Want to combine this cavity B for the bodies. Okay, so here we have our our B plates, our B B cavity plates has been the cutout has been created already. So now next up we are going to create the cores and they are both cavities. So the part doesn't has a core. So and we're also going to make the cutout for the cooling line as well. So let's make it for plate B. So go to combine, activate this one, then activate the gate as well, then the cooling line. Okay, so we do for the A plate as well. Then just like this, and combine, and this is the cooling line. Yeah, okay. So we can offer this turn off visibility to just to cross check if our cause and cavity was perfectly created. Now I'm getting the loss. So this one is okay. Then let's check the B plates. Yeah, it is okay. So let's make a section analysis to see if the cooling line was how well the cooling line was created. So let's play 12. Let's go 20. Need more 26. Yeah, so this is our cooling channel. Yeah, so I think they are both perfectly created. So from 8A on, So how we are going to go about this project is we are going to first finish the injection side, then this A plate. Then after we are done with this injection side, sorry, we go to the other side, the ejection side. We complete the ejection side. So that's why we are going to go about it. So to start this mode design, the first thing we are going to first start by creating our cavity plate. So to create the cavity plate, you go to the mode based session, click on cavity plates. So we are going to input our parameters. So for this, we need 520 mm, 560 mm, then the thickness of the two plates are equal. So put it both 55 mm. Okay, then we can hide this for now. Then we'll go ahead with creating the mode base, the main mode base. So we are going to use Haskell standard mode base for this mode design. So we select yes for the cutout option. The use of the cutout option has been in one of my previous videos. So the size of this mode is 696 by 696. Then the A thickness 66, B thickness the same thing. Then C thickness 96. We don't need this, so we leave it at no. Then okay. So it starts. So that's our mode is created. As we have all our components of our node created. So let's start by making a cutout for the cavity. So we just go ahead and hide the bottom components. This is cavity B. So this is cavity B. So we hide it. Then combine made already made a shortcut for my combine function instead of us going back to our solid menu and our utilities menu back and forth. So I created shortcut for most of the commands we are going to use. So we are going to make a cutout for the cavity plate. So this is what we want to cut, and we make sure keep tools is active. Okay, so our cavity plates for our A part is done. So let's do that for the B part too. Want to combine this cavity B only for the bodies. Okay, so here we have our B plates, our B cavity plates has been the cutout has been created already. So now next up we are going to create the cores and they are both cavities. So the part doesn't has a core. So I'm also going to make the cutout for the cooling line as well. So let's make it 4 plates please. So go to combine, activate this one, then activate the gate as well, then the cooling line. Okay, so we do for the A plate as well. Then just like this. and combine combine and this is the cooling line. Yeah, okay. So we can offer this turn off stability to just to cross check if our pores and cavity was perfectly created. Now I'm getting the lots. So this one is okay. Then let's check the B plates. Yeah, it is okay. So let's make a section analysis to see if the cooling line was how well the cooling line was created. So let's 12. Let's go 20. Need more 26. Yeah, so these are cooling channel. Yeah, so I think they are both perfectly created. Yes. So it's a on. So how we are going to go about this project is we are going to first finish the injection side, then this A plate. Then after we are done with this injection side, sorry, we go to the other side, the injection side. We complete the injection side. So that's what we are going to go about it. So first thing we are going to do is we are going to create the screw and the dual pinholes. The one that is going to hold the cavity and the core plate and the cavity plates as these two plates. So I think so I'm going to we'll hide the top clamping plates. So we'll use this plane to create sketch. So we'll project project all these screw points and webbing points. So this one, just love projecting circles rather than I love projecting cycles rather than points. Okay, that was 11. I think we projected 1 point double. Sure. Finish sketch. You know, we go back to our utility star. So, yeah, six. We have six screws. So we're going to yeah 6 screws. So it means we are going to from our DN5 side we are going to create 6 sets of socket head screws. So you go to your socket head screw 6 sets and you say select the points. You just pick the points. This is the first point. This is the second point. This is the third point. I just hope you are correct. Fourth point, fifth point, and this is point. So we are using 10 mm. So the length of the screw is 35 mm. Then only the trail length of the 25 mm will be okay. You hit OK and wait for it to finish creating the screw points. So now you can see it's created it. upside down, so we are going to edit it so they fit in correctly. So the way the RNA fastener was designed, so the other commands were hidden in the timeline, but the joint command is out, so you can easily edit it. You can also get the RNA fasteners from the App Store, Autodesk App Store as well. So we hit flip, and let's go for a distance of offset distance of minus 10 mm. Let's see if it's the correct, yeah, positioned correctly now. So we'll do that for all 6 of the screws. Flip minus 10. Okay, flip minus 10. Oh, don't think we flip that correct. I don't think we flip that thing. That's the third one. Flip, yeah, correct. And the fourth one, minus 10. Flip. Okay, minus 10. Flip. Okay, minus 10. Flip. Okay. So we are going to confirm if the screws were properly, if they are properly created, and if they actually engage the two plates properly. Yeah, so there you have it. So I think that's just enough. So we're going to we're going to cut out the holes for the screws. So let's bring out all the bodies. Yes, yes. You can see you already have a cut body for the screws, so you just let's see cut body. So you need this plate first. So you just select only the cut bodies. Okay, okay, yeah, that's 12, correct. Right, okay. Then also cut out the inner plate as well. Yes, 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 yes. Let's see if we have anyone at the bottom. Yes, yes. That's 12. Then you can hide hide the bodies. You can also hide the sketch as well, because as we move on, we are going to be creating lots of screws. So this our design workspace will be crowded by sketches. So let's start hiding these ones for now. Yeah, so you have our screws created. So yeah, so all our screws for the place are being created. So now let's create the holes for the door pins. So E4, E4, we hit E4 extrude. So this point, and this point. So we can just, since we don't have anybody obstructing it, you can just extend this to any length we wish. So now one thing we are going to do first is to cross check if the door pin hole is interfering with the filling line. I think last time we did Section analysis, I think we went for minus 25. Yeah, that's well enough. It's very close. This is not interfering. This is not interfering. About this, I think we have to. So we are going to create new sketch points for the weapons. So let's turn off this section analysis. So this was the sketch. So with this sketch, I think we should go for 14 by 8 mm. So we can just mirror this with mirror line. Okay. And select these 2 points. So let's mirror line. And so now let's try it out and see if we have if this will be if there will be any interference with the cooling lines in this way. Let's take it as long as possible. So let's turn on back our section analysis. Yeah, so the interference here. Also, all is there are no interferences with the cooling lines, so we can now go ahead and create our lower pins. Let's write these ugly sketches. So this we don't need this aspect for now. So we can now go ahead to create our lower pins. So just click on the weapons. It's on the front command. So we will be needing 8 mm, then we'll be needing 60 mm inlet. Okay. And so how it's created. So you might try to make an array for the make an array of all the weapons. So you just join it the other in the other counting holes. But if you create an array, the adding would recognize it as another additional component. So the way to do it is by if you want to create multiple single components is to just repeat the command or the adding. So if you use an array, it won't recognize it as a new component in your design. So hence we are going to repeat this 4 times. Okay. 60. And so our dual pins there has been created. I can still do a session analysis to just check if it's nice. And so let's say minus 78, minus 85, or 89. Let's say, yeah, so yeah, these are dual pin, so it groups the 2 components properly. So now, next thing I'm going to do is I'm going to create the screws that will hold the top clamping plate and and the main cavity plate. So this screw is M20 screw. So we're going to, we have four Fleming numbers. So we are going to go to socket a screw forceps to press the four of them. So you just select the points, select the second points, select the third points, and so you go for M20, then the length of 120 mm will be okay. Now let's go for a thread length of 80 mm. So it was quite to do his job. Yeah, so those are screws created, and lucky enough for us, yes, it's just okay, and lucky enough for us, it's just dismounted on the exact point and the exact direction we want it. So now you have to create the cutouts for the screws. Okay, and you have your bodies, stretch out your bodies. Let's just do a quick session. Let's do a quick session analysis first to see how they fit in. Uh, it's meant to be this way. So, I think that's enough. So now we can go ahead with putting the bodies. Spacebar for combine. Again, I repeat, I customized that as a shortcut on my design. So if you hit spacebar on your own, I think it might just go ahead and select under command. I don't really know. Yeah, so that's complete. So let's also do for the cavity plate itself. You don't need this one because they're not connected together. This one only connects the top clamping plate with the cavity plate, with the main cavity plate. It's the not the cavity insets. So it's okay. Right. So we can go ahead with hiding, just hide the cut bodies. So hide the stitches as well. Yes, I'm going to hide those joints command because they are not coming. The whole space is now becoming crowded. Joints. Um, just hide that now. Yeah. So that's that's how schools created. So what we are going to do next is to create next we are going to create the guide pins for the mode. So let's guide our top clamping plates. So we are going to make use of guide pin with color. So select the 4 points. I want to create the all guide elements commands. Apart from the rectangular guide elements, you can create your 4 guide elements all at once. So we'll be needing 200 mm length, but it's not available. So let's go for 195 for shoulder length. Let's go for 56. Hit OK. Uh, wait for it to do its job again. So we have our guide elements created. Now we'll do a selection analysis and to see if we selected just the right guide pin. Also section analysis. Uh, let's go minus 20 first. Oh, too small. Let's say 50, yeah. That's just enough. Yeah, so the guide pins are okay for us. Yeah, they're just right for us to use. So let's hide back our ejection side or the bottom half, anything you call it. Let's hide it back. Plate B as well. Yeah. So now we have our guide element installed. So next we are going to create is our locating rings at the back here. So let's create our locating rings first. So move over to the ejection side. So we'll be picking size 42, 47 for this. Remember, this thing are arranged in order of increasing sizes. So there you have your message components at the origin, which means your component was imported successfully. So we hit M for move, uh, go over and select the components, ensure that um, capture position. So we hit J for joints to take it to where we want it to, right at the top of the mode. Mm, join it here. So hit OK. Now I'm going to create the cut body for the injection for the locating ring. So we had our top counting space first. So I'll go to surface. You can use this to be a very good tool for us to use. You hit on patch and then you patch there. Also here, patch here. Now let's create left solid. For that is solid left. Select this profile. I think we need to hide these stones. Be able to see the maybe select this profile. Now we need new body. Okay. Yes. Over that. Now let's turn back on our top clamping plates. So now we can cut those. Let's go back to our utilities menu. You can cut this and make sure keep tools is active. Just look for that body over there. Yeah, here it is. Thank you. Also, we can hide those. Yeah, so that's our locating ring fitted over there. So now let's go ahead and create our sprue as well. So sprue. So we said we want it 18, only 1856 for 116. Yeah. The mode is quite a high mode, so we need a long sprue here. So it's component at the origin. So we repeat the same process we did for the locating ring. M for move, right out, capture position, uh, need Yeah, so I was present fitted yeah, so also creates the port body for the sprue as well. We do the same thing by hiding a top clamping plate and the stability plate to create the hide this transfer and hide plate. I think you might not need to hide the rotating ring. As the of the surface touch uh, move down here, touch and press, you create a loft again. Um, and select the other profile. We need this to be a new body. Next one, let's turn back on our mode place. Look, turn off this key and we got it insert here as well. Space bar combine. Um, but let's combine the top clamping plate first. Okay, then we wait for the cavity plates as this. Let's go around to screw and just have a lot that can just select the body from here. Okay, so now let's do that. Let's do the cavity plate as the cavity insert as well. And, and this over. So move up to the other body is mm, okay. Yeah, so they will have they will have a screw. Let me just like that. Hide it right. So our plastics are going to come all the way from here into this area. And so as our screws fitted, so one thing about this screw is there's a kind of a rest axis in the screw that enables the nozzle to sit perfectly in the screw. So we are going to also go ahead and cut that like this. I think we don't need to hide the rotating ring. So to create the cut body for that, we use the surface tool again. You go and patch that hole. Then we look for offsets there. Then patch this place as well. So I'm going to stitch all the surfaces together. So one thing about and see if it creates if it's going to create a solid body. So in future, one trick is if you stitch two or more surfaces together and they form a perfectly closed boundary, it's going to automatically create a solid body for it. So you see, that's what it's created. It's created a solid body for us. So just go ahead and put it. So now it only interfered with the top clamping plates. So we pick our top clamping plates and we just go ahead to make sure we're actually selecting the right body. Okay, so hide that. Is there any other body interfering with it? Let's check. No. Oh, so when we created, what happens when we created that? When we put the body, it's created another body together. So, that's what happened. So now have our body together. Yeah, so our screw fits perfectly in there, but those holes, those uh, portals in the screw still form some cavity here. So you just go ahead to find a way to get rid of them. So that's- it's not picking it as a profile, so it means the body is not perfectly flat. So let's see if Crespo can do the job for us. So let's go -2 first. Or 2, 3. Let's go 6. Yeah, so my body's disappeared. So let's go for let's go for let's also take away this one. Uh, let's see, it's as friends before. Yeah, so also disappeared as well. Also leaders. So let's make a session analysis to just take a look at what we did here. So that's fitting nicely here. So okay, okay, let's just take a look at it again. So yeah, so I think the tolerance I gave you was a bit too much. So let's just reduce that. So let's pull. Oh, that's the wrong face. Let's move. So let's say 0.2 pencils. Let's go. Oh, one. Let's go into too small. Let's go one. Oh, this okay. Let's see. Yeah, I think it's just right. Yeah. So when the excessive pressure, it won't push plastic material into this area. So I think that's okay. Okay for now. Let's say done.